Hello, everyone, and good evening, and welcome to this session on Intro to DevOps and Azure DevOps offering. So, we have Karthikeya here with us. He's a founder of OpenCo and is also an organizer at Azure Developer Community Raipur. I am Abhishek. I'm an organizer at Azure Developer Community Bilaspur, and we're here to bring you this amazing session. So, how things will go is Karthikeya will firstly introduce you to DevOps, what it is all about, what are the terms related to DevOps that you keep hearing all of the time, and all of the basics to get you understand what DevOps really is, what it's all about, and how you can basically start with it. At the last, I will come up and tell you something about what Azure has to offer when it comes to DevOps. And between this period, please feel free to ask any questions in the comments. We'll be keeping an eye on that. And we'll also have a small Q&A session at the end. So if you want to ask them any questions, then you can definitely do that. So Karthikeya, please take it away.
Cool. Thanks, Abhishek. As Abhishek already introduced me, let I think so. My screen will be visible. Let me bring this. Cool. And sorry for the background news, folks. It's so many dogs are barking. So yeah, cool. Cool. Hey everyone, this is Karthikeya. Talking about specifically for my Azure community. I'm an organizer at Azure Dev Community Rapper. And today we talk about what is DevOps. I also include containerization here because it's a core part of DevOps, and why it is necessary, what it is like. Let me go into. But before going into the next one, I hope so many people see this meme. And there's quite frankly kind of thing. Even people saw that you require 10 plus year of experience in Kubernetes and management kind of stuff, but reality is that it is not older than 6 year, and that's a kind of meme like I don't see her over that end. Cool. And yeah, let's jump right to the main of thing. So DevOps is equal to development plus operation. So the term like basically is coined on the focusing on like how as a developer you also have to work with the IT operation team. Like if suppose your startup or your company is building a web application or like a mobile app, suppose, and you're deploying that particular product on the maybe on the cloud and anything. So sometimes it's like it can be possible in a maybe first version it can be see like that, like many people are surfing around your website or your mobile app, so it can be part of crashing kind of thing. Cool. So now on that basis the IT operation came into play. So just to remove that, or just want to improve the, you can say, the timing or kind of stuff with the managemental end, they created a role kind of in DevOps, or you can say DevOps engineering. That is the particular folk have a knowledge of development also, and have also knowledge of operation, how to handle the whole production issues kind of thing. So that's the concept came into DevOps. Cool. So let's straight to the main topic, that is containerization or containers. So from the term named containers, what did it mean actually? It's mean you have to contain something. Cool. So the concept bring out here is like how it created and how it coined. So when, as I already stated, when development is having IT operation stuff is going on. So again, if you suppose you have a web application, and again when we say in cloud computing, the web application is like that, you have to be in the, you have to create a VM instance. And those who didn't know what is VM instance, is a virtual machine. And just you can say a small property, like suppose you if I'm going for the ops end. Cool. Ops means object oriented programming kind of thing. So where what we do, we have a class and we just create an object to use the properties of those classes. So it same here, it's happening on the same. We have a website, so what we are doing, we created a VM instance for that particular machine. It is not actually available in hardware stuff, it is available in the cloud, and we are using as a property, you can say. And for that, for every web application or for every resource, yeah, small container is to make, so that it can balance the load that is due to the traffic it is going on to, or you can say internet traffic. And that's the concept bring out of the containers and containerization, and the concept built out. Cool. So let's deep dive into the next one. Now, this is also quite, I think, so familiar. Those who are like pretty much in DevOps community, they pretty much know before DevOps it works on my machine, and after DevOps it works on my container. So what is the meaning of here is like that, like when there is no cloud computing, when there is a no DevOps kind of thing or containers is there. So actually what, like, suppose if I'm taking an example of VM instance that I already taught, is like that. Suppose I have a hardware, suppose maybe 4 GB RAM, maybe suppose 1 TB of HDD I'm having, kind of thing. So same thing is happening after container. It's just happened to in the virtual end. You have not a hardware in your system right now, but the scene is here is like that. You are just using those resources in a virtual environment. So that's a basic thing. If it is not your hardware machine, that means it is on your container. So that's a kind of a meme, you can say. So yeah, let's jump to the next one. So why there is a need of you can say containers, kind of thing. So we will go to the point of it save times. How it save times, that's our main question. Like, if we are using containers, how it's saving our time. So the first pointer is like that. If I'm taking an example, if I'm not using container, suppose, okay, so again, if I'm loading anything or if I'm doing any stuff, specifically on the maybe I'm just going to the maybe GitHub action. I'm taking an example here. There are so many famous CI/CD tool, that is GitHub action. And when people say it save time, what is the meaning of save time? Because it is an n number of containers, and every jobs or every roles that is decided for every CI/CD is given to per containers, a very small container, very small size. So again, if you have a concept of parallel computing here, it's just like that. You working with the n number of things in a small way gives you a safe timing, kind of thing. And also, if you're working in a maybe a fully fledged maybe computer or laptop, so it takes time because it is happening not sequentially, not parallel. It's going in a one way. So again, containers save your time on that end. Cool. Now, second one, it reduces the cost. Now, I think so reduces cost it's a like very simple kind of thing, maybe because you didn't have to buy anything. You just have to use the VM instance that is available on the cloud. So that's the power of you can say containerization and DevOps services on cloud services. Cool. And third one, let's see. So you do not have to configure our hardware. Cool. So it's not like that. Yeah, like you have to be a great system to use that particular VM instance. No, if it's a very basic kind of thing. Like, if you have a maybe I'm taking it on Windows 7 operating system, you're connected with your internet, a small kind of you have to just need to create an environment and just directly use those VM instances, use maybe for the supportable platform, kind of thing, that is Azure is providing right now. And why people say Azure, maybe other cloud services like AWS, or you can say GCP. So these are all under the fame of due to this thing, because you do not have to configure any hardware over their virtual systems or your environment specifically. Cool. So let's jump right to the next one. Don't spend time installing operating system and hardware to host a deployment. Now, why I'm saying this? Before DevOps, before any cloud computing services, what we do initially in terms of API also. So there is a command we know. Those who know pretty much API testing, it's like a curl command we will use to test an API. Now, that particular API will be run, or that particular that server, or you can say local server, running on our system. So again, if you didn't have a capability of hardware, you may be not able to host or maybe do something like that. If anyone who is a follower of Elon Musk, he's sharing his journey on that only. Like, he created his website with his brother, I think so. That's the story of PayPal. And at the night he stayed, and like he wake up and he's just doing the whole stuff, or you can say updation on the website. Is it like buggy or kind of thing? So that's, again, it's the whole thing is happening on their system, not on locally, or you can say hardware stuff is going on. So that's why you don't spend time installing operating system and software to host a deployment. Cool. Now let's jump right to the next one. Now, containers are isolated from each other. What is actually its mean? Cool. So if I already stated that when it save times. Cool. So if you have n number of containers, a small job is given to every container. So every container have a different environment. It can be same environment, but they are isolated from each other. Why it is necessary? If it can be possible, like, suppose I created 10 containers. Cool. And in 10 containers, maybe in the initial 2 containers, they have a same, you can say, configuration, and last 8 have a same configuration. So why didn't you take an isolation, just have a combination is like that? So actually, what can be possible, if one container have any bug or any production issues, that total suffers a whole series of containers. So that didn't we want. because again it will crash your whole product, or that is the product that is deployed on the cloud services or that particular system. So that's why containers are isolated from each other. Cool. Now multiple containers can run on the same hardware, and yeah, that's a scene, because as I already stated over here like when we say containers are focused on the same hardware, and how it is possible. Now the scene is that when we say configuration, like one TB of HDD or multiple kind of thing, so again every container have a, it can be possible one container have 1 TB, second container maybe 3 TB, 5 TB, but it is also possible like n number of containers have the same configuration. So on that end, again containers are really helpful on the same hardware. Like again when we say virtualization in cloud services, what actually means is like that it focuses on more on the containers to build it off. Cool. Now maybe go to the next one. So what is software containerization, and yeah, why the coin term software containerization came into play. So now the challenges we face is, I will take this as a maybe a question to just put it out over here. So yeah, management of hosting environments. So when we say hosting environments, it's just trially morely focus on how you are creating your environment. Like it can be possible for, there is a one environment which is for Python development, second environment maybe for the Ruby development, or maybe you're creating a web app using Ruby or maybe Rust kind of thing. So again, they have a some minimum amount of you can say requirements and environment setup over there, and that's a whole management hosting issues are created during your production issues. Because when you're working with production side, you pretty much know there's most only the memes kind of thing, like Friday, Saturday, Sunday, there is a crashing kind of, most chances of crashing is there. So that's the point is came here, like how you can manage the whole hosting environment. So that's the answer, that is containers is the answer for that. Cool. Now, second, continuity in a software delivery. So as I already stated, like when we say an example of GitHub action, that is CI/CD, continuous integration, continuous delivery. So the first one, if you are putting any product on the hosting side, the main priority is here, you have to be continuously delivering that stuff. That is continuous integration. If you are working, like there is already set up the product, there's a first version is issued on that particular production side, and you're working on the second version. So again, first version should be live, and second version, it has to be deployed as per as the timing goes on, because you didn't want any production bug issues on the production side. Cool. So again, it helps in continuity and software delivery. Effective use of hardware. So again, you have to access one hardware, and using that same hardware you can do n number of you can like create n number of containers or n number of container instances that we will saw in the end about the how you can create an instance at Azure like on the Azure Dev portal. Again, Abhishek will explain that pretty much. Cool. So yeah, let's go to the next one. Application portability. Now what does actually mean when we say application portability? It is majorly focuses on how you like I'm taking an example over there. So if you want to port if you means to port one application version to another application version, I mean to say, suppose you installed Snapchat. Cool. So maybe the version maybe 2.0.1 you are installed, and now when we say application portability, it means the versions, how you can improve or port your first version to the another version. That's the main. So that again, containers help in that way. Like suppose you created three containers. First container is referring to version 1, second container is referring to version 2, and third container referring to version 3. So when we say application portability, it means like when you're working in your production side, what you can do, if you're maybe you are installed Snapchat, or you are using Snapchat on containers. So it is again, you can switch the version from a one container to another container, which means first version to second version to third version. So that's it stated, like how containers are really helpful in application portability, and that is majorly focusing on that thing. So many people see this meme is quite funny, maybe Docker. I see Docker everywhere. So that is pretty much because most of them, if we are many of them are students, so they pretty much use Docker as a, like again, Docker is a container, and how we can use it, how we can work on it. So like I'm just giving you a small brief introduction on that end. Cool. So yeah, Docker is basically is again a container, and how it helpful. So let's go to some Docker architecture, because I explained the container. So how again Docker is a container, that's what we stated, and how the whole architecture is focused and how the Docker works. We are not going on the working, but I am just going to the you giving touch of how the whole architecture works. Cool, in Docker. So let's go to it. Cool. So as you see here, Docker Hub contain your maybe the main operating system, that is your Linux, or the environment, basically Windows, Nginx, and that is this is the one thing. The second thing is Docker host, where whole Docker engine and basically Docker server, REST API, and Docker client, basically it is located here. And what those who pretty much in DevOps, they pretty much know in this one, we have to create an image. You didn't have to create a whole, you can say, environment for that. You just have to create an image. You just need to call that image while creating your Docker server, maybe REST API, or maybe or that particular Docker client, using Docker Hub, that is maybe you are installed in your system, or maybe on the web end, so you can use that, and just pushing that image to the containers. This is the whole workflow of Docker. Why Docker are very predominantly high in students is like that, because sometimes it can be possible you are building a project. Cool. And you have to be you are releasing the product or releasing your project in a release form, that is in version 1, version 2, version 3 kind of thing. So what Docker helps here, again the same thing. If there is any bug or if any issues on the version 2, so again it directly call version 1 only. Till then the version 2 has a successful build, and you can say the working specifically on the different requirements or different environments. That's the majorly focus on the Docker Docker architecture. Now what is Docker Hub? Now how Docker containers works and manages, that's the main thing. Because when we say Docker Hub is a, you can say, is a platform where you can create your image. Again, you are creating main locally, but you have to push your image to the Docker Hub. And what is Docker Hub? It's like suppose I'm just taking an analogy. It's kind of a GitHub kind of thing. Why I'm saying here, on GitHub, what we are do, if you want to contribute in any open source project, what you will do, you fork that thing. Cool. You just copy that thing. You just made some changes that push that thing. Same thing happening with here. You're creating an environment, taking up, forking it that thing, and just you have to change your requirements and push that thing to the up. That's the main thing is going on here. Cool. Now, just a small workflow of, you can say, Docker. So first you have to create an instance. The Docker run is a command. It's running, and it's totally on the depend on, you have to pause or you have to like repause that thing running. Again, if you want to remove the Docker environment, you can just directly use the Docker. Otherwise, Docker stop. And if you want to restart that thing, like it's like a server running kind of thing. So Docker run is just a process of the whole server thing. And if you want to stop, restart, so that's a different workflow that we are seeing. But the majorly focus in Docker run. And if it is crashing or like is there any production issues, it will show on your terminal. And yeah, that's the main you can say in and around thing kind of thing. Cool. So when to use Docker containers? Cool. That's a main thing. So if you're hosting multiple environments, I mean to say, like you have a product, or let me take an example of Julia. Cool. So Julia have when we say Julia is a programming language, and we say if we are creating any project under Julia, so what can be different variant? Again, it can be you are creating with your core Julia language. Second can be if you are working with there is a language, or you can say framework called flux.jl that is focusly majorly on the machine learning flow for workflows. Third can be there is a Janela.js that is basically a Julia format of for creating web applications. So if you're working with 2 to 3 environments, so you have to manage that environment, and you have to push that. Again, the whole Julia setup is working on that thing only. If you want to manage or host multiple environments with very ease, that's the main reason that we are working on it. Cool. Second, guaranteed continuity and how we deliver a software. Again, at the end of the day, I am just take an example. Software is we are building, but again, what it is used for business, right? We are working for the customers, right? So we have to maintain the experience to be good. So for making that continuity in a flow, we need a guarantee kind of thing, that basically CI/CD that we came into play, like Circle CI, GitHub Actions, and many more kind of things. So that's the power of maybe Docker here, or container specifically. Ensure we make efficient use of server hardware. Again, it can be possible, like if I'm saying suppose I have 10 containers. Each container, if I created with 1 TB, cool, but each container is using only suppose 5 MB. So other like you can say other space of that 1 TB will remaining as you like, it's like a kind of a phase. So what they are doing is just focusing on, they're just creating a 1 TB. If they saw, if it's if they exceeding the 1 TB, then the whole another kind, that the doubling, that their doubling kind of thing has happened. And over that thing, you are increasing your memory, but it is again, it's a, like a production issues kind of thing. And because it can happen, because sometimes memory can overflow, that we didn't want. So that's why it's just doubling the whole thing. Cool. Allow for the portability of our application. Again, as I already stated, you can port it from one version to another version. So that's the thing that we talked. So Docker benefits. Effective use of hardware, as I already stated. And when we compare, let's compare some hypervisor thing with the Docker. So hypervisor is simple. Those who didn't know, it's just not a VM instance you are creating on that end. So when we say you didn't have to create a, like in the, if we say in the left side, that is VM guest operating system, that what we are seeing, we didn't require in the Docker. Why we didn't require in Docker? Because again, it's created its own environment. What hypervisor is doing, hypervisor and VM guest OS is what they are doing. They're creating the environment for the host OS. And host OS can be Windows, Linux, or Mac OS, and like, or you can say any version of you can say Ubuntu or Linux kind of thing. So that's a majorly focus. And Docker, again, as I am stating in the previous workflow, what we are doing, we are creating an environment, we are pushing that thing into Docker Hub, calling it back to the our local system in order to changes our versions. So that's the power of Docker that we are using here, using again Docker Hub. You can say another you can say containers, you can say GitHub containers kind of thing. You can say GitHub website for containers. You can say Docker Hub, simple as that. Cool. Now containers isolation that we talk again, but how it seems to be like. So if we are taking in comparison kind of thing, so app1, app2, app3, cool. Library 1, library, well, the same library. So I'm just stating out library 1, library 2, library 3, and same VMOS. That can be different operating system also, but it just totally depends on you. Now, when we say Docker, again, OS we didn't need. So n number of OS that is used in every application have just removed, because again, Docker creating the environment for that. And again, for the libraries also, again, you have to build out for the library or the version that we use in package.json. If you're working as a React developer or any web development site you're working on, that's the main thing. You're creating the library for that particular each application over there. So again, when we push any, we didn't push when we're pushing maybe our website, or you can say our web development stuff with on the GitHub, we actually, what we do, we use .git ignore and just ignore the whole package.json, because it's a whole mass of node module. We didn't want to push that thing. So that's the main thing is happening over here. Cool. Now let's see in action. So I just more particularly going on that end, because if we like actually we should state that in that thing, but I hope so. Yep. Most of the thing I have just touched it, and maybe Abhishek maybe carry up on that thing for the further thing. Yeah. Mods, maybe if mod can bring them on the stream. Cool.
Cool. So what you must have gotten up till now is what is DevOps and a little bit about what are containers and everything around it. So now what we're going to do is see what Azure has in store for you to make all of these possible at a central place. So I'll just share my screen. Cool. So the thing is, Azure firstly offers two kinds of products. One is Azure DevOps Services and one is Azure DevOps Server. So what Azure DevOps servers are basically on-premises servers that are usually used by large organizations. So they're on-premises, they're SQL backed. So what happens is if there's a large organization and they want like this CI/CD servers and all of the things related to DevOps in their premise, and they also don't want the code to, let's say, get out in the internet, they can use that. But right now, what we're going to talk about is Azure DevOps Services. So what Azure DevOps Services are is basically it's a SaaS platform that Azure offers you to do everything with DevOps on the cloud. So to access these, all you need is internet and a browser. We'll be looking at all of the components that it offers, all of the services that it offers. And let's start with the first one, which is Azure Boards. So Azure Boards is basically a service where you can have Kanban boards to plan your project. You can assign different tasks to different people. You can create deadlines. Also, it's Scrum ready. So if your company or if you are following Scrum model, it has all of those things about deadlines, about sessions, about sprints already integrated, so you don't have to worry about that. And that is the first feature that Azure DevOps services offer. The second one would be Azure Pipelines. So what Azure Pipelines are, uh, Karthike mentioned there are something called CI/CD pipelines. So for instance, let's say every time you push a code, you want some tests to be run on it and then only integrate it or merge it into your central repository. What you can do is create a basic CI pipeline for that, and that will take care of that. Also, another instance could be, suppose every time a push gets into the master branch or you commit something into the master branch, you want it to go through some test cases and then finally be deployed. That can be done through a CD pipeline. So Azure Pipelines is basically a set of tools that allow you to create those pipelines in Azure DevOps. The third one is Azure Repose, and it's very much similar like a GitHub, very much similar to GitHub. So it's a repository hosting service, and what it offers you is again a place where you can host your repositories. But here we actually have two kind of repositories. So the first one is a normal Git repository. Sorry, I think there's some distance. No, right. So the first one is a Git repository. So what you can have there is basically anything that you store on GitHub or Bitbucket. You can host those things in the Azure Repos or the Git repositories. And then we have something called TFVC type of management, which is Team Foundation Version Control. What basically the idea behind TFVC is that you can have a central place to store your code. So unlike Git, which is a distributed version control system where you have a central piece of code and then you have its local version distributed to all of the developers, here you can have a central place where you store all of the stuff. So your repository will be stored in a central server. Any changes will be made to that server. The history will be kept as it's kept in Git, but you won't have local copies. So that is something that you can also have in Azure Repos. And then comes Azure Test Plans. So I talked a bit about tests in CI pipelines, CD pipelines. So what Azure Test Plans allow you to do is create different types of test along with like different steps, as you can see on the image that is here. So you can have manual testing where you can list down the steps that a tester can just go through. You can have exploratory testing, or you can have a fully automated testing. So a lot of testing options that Azure provides you in the Azure test plans. Lastly, we have something called Azure Artifacts. So let's say your company or your organization, you develop a package that you want to be used with your CI/CD pipelines, or you're using an external package with some pipelines. No worries. What Azure Artifacts allow you to do is basically store those artifacts or store those packages in a place which can later be utilized by any of your pipelines. And those artifacts could be of any type. So it could be a Maven artifact, packages related to npm. And Azure like supports a lot of language. Mostly all the popular language are supported by Azure, so you don't have to worry about that. And let's not forget the last but the most amazing feature, which is the extension marketplace. So if somehow all of these features um, doesn't suffice or doesn't have all of the things you need, there's always extension marketplace. So what are extension marketplace? They are basically community and Microsoft developer extension that you can use in any of your projects, and you can hook it up to your project. Some are free, some are paid, but you can uh, use that. Kartike mentioned about Docker. He got into detail about Docker and things like that. So you can just go to the extension marketplace, have the Docker integration into your uh, Azure like DevOps services, and get up with it. So now let's talk about, these are all good, but how can you access it? So for that, what you can do is go to a link that is dev.azure.com, which are basically the home of Azure DevOps services, and there you can have access to all of these services for free at a starting point. So all of these services are free for some limit, and afterwards that you have to pay as you go. But initially, if you want to just try things out, see how everything looks like, everything works, you can do that, and it's completely free. So I'm just going to show you a small sample of what it looked like. What are the different components that you can see when you firstly enter that? So if you go to the link that was provided, dev.azure.com, you just have to sign up with your GitHub or your Microsoft account, and then you'll be greeted with a page something like this. So you may not have this test project, any project created, because it's empty by default. I've created the sample project just to show you what projects inside look like. So if I click in the test project, give it a second. And yep, so it opens up the summary or the overview of the project. This will basically contain the description, some of the stats related, the pipelines, and all of the members. So currently I'm the only member in this project, and that's why it's showing just A, which is Abhishek. Next, I mentioned something about boards, and this is what boards look like. So the first thing is work items. This is basically a list of everything that you've put. So every task that you've put will be contained here in a list format. So you can filter out, you can see things, and you can just basically fiddle around with those. Next, we have the board section, which is basically a more graphical representation of what we saw earlier. So here we have like two tasks. One was create an item, which I have already done, so it's done. One is show demo. I'm just going to drag it to doing. And what you can also do is basically assign it to anyone. Right now, I'm the only one, so it's showing me, but you can assign it to anyone. You can change the status by here, going to here, and all of the things. Also, we have backlogs. So I told you about sprints and how it's pre-built to support Scrum, right? Now, this is where backlogs and sprints come in. So you can design your own sprints. You can have backlogs. So, for example, show demo was assigned to me, and I made the date so that it could be completed, for, let's say, yesterday. So that's why it's showing me in the backlog. And here we can also design some sprints that you want to like. We can design sprints in, let's say, a 1 week gap or a 2 week gap, and have our team see all of these things and get an overview of what is happening. Then we come to Azure Repos, which I told you about. So right now I've not created a repo, I just created a README file, and it's the starter README file that you get with Azure DevOps Services. So that's it. In the repos, you can also see all of the commits, all of the pushes, pull requests, tags, branches, all of the things that you might have seen in GitHub. You can also get that here, and much more if you using another type of version control system. Next is the pipelines that we talked about. So you can create different pipelines, see that can run automatically at a different time. So I did create a pipeline, it failed somehow, so I must have messed up somewhere. But what this pipeline did was basically whenever I pushed my code, it would basically run some test cases, build it, and see if it's working. So that was the basic pipeline, and well, it failed, but you get the idea. So you can create these pipelines, and yep, set up CI with Azure Pipelines. You can have multiple stages in a pipeline and all of those things. We have test plans that we told you about. I've created a simple manual test, so you can have as many tests as you want. You can also grant people who are not in your community, sorry, in your organization, permission to do tests. So let's say you have this project and five people have the ability to see all of those things. For test, what you can do is you can have external people that can basically do a manual testing or an exploratory test on your on your project without giving them access to the entire project. So that is something really cool that also Azure Test Plans offers. And finally, so we have the Azure Artifacts. Now, I've not created anything here, but here's the place where you can have your packages or your artifacts, and you can basically create a feed. So what creating a feed means is basically you can connect it to an artifact or a package that you're developing, and it will automatically get all of the data and run all of the things that you've specified. uh, what I can say is in the pipelines also it can support various types of pipelines. So you can have GitHub pipelines that are YAML based, Bitbucket pipelines, and really it basically offers you to create pipelines from variety of sources. So not just GitHub and Bitbucket. You can also create a brand new pipeline here also. And so that was the basic overview of what Azure has to offer. And the reason why I did mention all of these things was because uh, this was an introductory section. So this was a session where we just explored what DevOps is, how you can get started with it, maybe how what Azure has to offer. From now on, what we'll do is we will be covering all of these things, all about boards, repos, pipelines, how you can get started with DevOps, container orchestration, and all of this big good stuff in the next session. So this was basically the intro section, the 101 of DevOps. And from the next session, we'll be covering everything that you need to know to actually implement this stuff. So this was the place where you got the knowledge about what things are. And next, we'll be having everything related to how you can actually implement things uh, when you want in Azure. So those are the things that we'll be covering the next time. So now we are open to any questions that you might have. And Kartika is also here. I'm also here. So uh, we are happy to take any questions that if you have. I'm just going to wait for 2-3 minutes, see if there are any questions popping up. Just going to wait for 2 more minutes. Are you going to get any swags? Funny that you mentioned that, because right now what we have is on a Azure developer community Discord, we have some quizzes going on. So you aren't going to get any swags for this session, but what you can do is go to that quiz, attend it, and if you're in the top 5 people, you'll be getting Microsoft swags. So how amazing is that? I don't see any more questions, folks. So we're going to end this session. But before we leave, I just mentioned something about Discord. And we also have Lakshit, who's going to tell you more about Azure Developer Communities Discord. So Lakshit, you can come up. I think he's not here. So what we're going to do is, uh, after this session gets over, we'll just have the Discord link in the description, I think, or in the chats. You'll find it somewhere, either in the description or in the chat. You can join in. And remember, we are having a quiz today. I think it's already started, so you can go there, answer some questions, and if you are in the top few top few people, you'll be getting exclusive Microsoft swags. So that's something to look forward to. Lakshit is here. Lakshit, you're on mute.
Okay, I'm sorry, my bad, guys. So, guys, this is the Discord link you have to join. So today we have quiz scheduled on the Azure Developer Community Discord server, and there is a so in that server there is a channel named Quiz. So their quiz will be live in that channel. So it will be live at 7 p.m. sharp, 8 p.m. sharp. So join the channel, and you can get exclusive swags from Microsoft, and top five winners will be getting the swags. So see you then, guys. And like we do multiple quizzes every Friday, so do join. And thank you, Karthikeya, thank you, Abhishek, for being a valuable speaker, and thank you everyone for joining in. I hope
Thank
we
you.
will see you in the future. Thank you. Have a nice day.
Thanks, Lakshit. Thanks,
Thank you,
everyone.
everyone.